Okay, so the recording should start now. Very good morning to ladies and gentlemen. Welcome all of you to our very first ISA Malaysia monthly webinar series. And I'm Ping Yang, your moderator today. And first and foremost, I would like to thank every one of you for allocating your leisure time or your free time for this precious Saturday to join our very first webinar session, and it really gives a lot of support and motivation to our speakers and the organizing committee. And we will try our best to keep this series going for the benefit of all. And for those friends and colleagues who are unable to join our session, they can later refer to the recordings of this session on our YouTube web channel, which is shared in our chat room, the ISA Malaysia webinar channel. And we will hopefully by next webinar, we'll have a concurrent live stream on YouTube to allow a better, wider audience. So before introducing our speaker for today, I would like to invite our ISA Malaysia's president, Mr. Sharul Rashid, for an opening remark. Right. To you, Sharul.
Thank you, Penyang. Welcome to our inaugural series of webinar brought to you especially by ISA Malaysia. And thank you, Penyang, for enabling this platform. It is quite an exercise, and I'm excited to have this series of webinar. This is actually a special project, and I really appreciate your time. I'm sure you have options to spend, and for a very good reason, you are deciding to spend this time hours together with us, with ISA Malaysia. Thank you very much. Thank you. And I would like to pass to the speaker, Suren, to deliver his talk today. Okay. Thanks. Back to Piang.
Okay, thank you, Sharul, for the opening remarks. And now, I would like to introduce our speaker for this session, Mr. Suren, who is the Senior Principal Engineer from Petronas. And he will be presenting our topic for today, digital transformation at all levels for automation-specific strategic projects. Welcome, Mr. Suren. The stage is yours.
Okay, hello, everybody. You see, I'm catching my breath a bit because I had to go down and pull in the clothes in because I sent my kids for badminton. So my neighbor rings the bell and asks me to do this. So yeah, these are common distractions. Anyway, since we're all human, let me catch my breath. So thank you all for coming. And so today I'm going to share this session for our first webinar. Hopefully we can have more participation coming up in the future. Yeah? So let me just proceed. I will give my background introduction in a bit. Is my slide moving? Okay, so myself, I am Surendran. I'm a Malaysian, born in KL. So I grew up in PJ. So now I live in Subang. So basically city boy lah. And I studied in Sri Kelana. And I went to Seaport School, Budak Sekolah Jahat, which is now, it's so jahat that now they had to change their name from Seaport to Sri Permata. So that's my school. And then I eventually went on to Royal Military College for the last 2 years of my schooling. After that, I went to UTP. So I'm Petronas Green Blood from the time I studied my university studies. I did electrical and electronics there. I'm the second batch of UTP scholar, UTP graduates basically. So at the time it was still Institute of Petronas, but then it became University of Petronas. I joined Petronas in 2002. Okay. And currently I'm the principal engineer in Petronas. So I have 8 years of, I was 8 years in MTBE, which is a petrochemical plant in Gebeng. Okay, I was doing operation and maintenance there. And then I spent I came over to GTS, and I've been 11 years in GTS. So we're doing consulting for the whole of the group. Okay, so I'm also a professional engineer with the Board of Engineers Malaysia, and I'm also a TUV functional safety engineer. My expertise in the area of turbo machinery, fire equipment controls, and also functional safety assessment. So this is my area of interest. Okay, so this ISA webinar series is something that we initiated, and I think over the last year, I think the global ISA also was doing a lot of webinars because of the pandemic, and there are 4 key areas. We don't necessarily need to follow these areas, but today's topic will be part of the digital transformation series for our mission section. And if you want to know more, you can of course go to this website. You can even just type it on Google. It will just probably bring links to you. But a lot of these sessions are only open to members. Actually, ISA members. There might be some free webinars, but it could be members. Anyway, today's session is open. We have tried to we have a small number of membership in the Malaysian section, so we want to try to increase that. So we have tried to gain interest and open up the session for today. Okay, so what am I going to go to today? So today, I just want to introduce automation. What is automation in Petronas? Then I will go on to explaining what digital transformation is about, how is it impacting us, and I'll just share with you some of the projects. These are not exhaustive, of course, there are plenty others, but I'll just share just to show some relevance. The introduction to automation in Petronas is quite interesting. I think somebody mentioned that until today, there are a lot of people who don't really understand what instrument and control is it's all about in Petronas. I get this question all the time. It's very difficult to explain from an engineering field, right? Because everybody talks about are you electrical engineer, are you mechanical engineer? But when we talk about instrument, people don't understand. It's so difficult to explain to them, but so maybe this session can be a bit of an opener. So yeah, so I'll just go straight into it. So let's talk about automation and the instrument engineer in Petronas. So in Petronas, we call automation engineer basically instrument and control engineer. So let's talk a bit about Petronas as an organization. So what is it do we do? So we are a fully integrated business. So we are basically exploring and drilling crude oil and natural gas from the sea or on shore, and then we add value of this hydrocarbon throughout the value chain. We produce liquefied natural gas by cooling down the natural gas, and we sell that. Then we also have gas processing. When processed gas, we send to pipeline for other industries to use. We produce liquefied LPG gases for household residencies, and then we also send this gas to be added value by converting the hydrocarbon chain into petrochemicals for other uses as well for our day-to-day lives. And for the oil, we send them to refineries, and then we sell them as petroleum products for aviation fuel, your cars, and all that. So as you can see, like in our assets, right, we have like about, right now on count, don't quote me with the numbers, more or less, we've got 215 offshore platforms. Okay, this is both Malaysia and international waters. They are both producing oil and gas. Okay, and these LNG plants, you find them in Bintulu, and now we have floating LNG assets, which means that they produce the LNG like almost very close by to the oil fields itself, so that it saves a lot in terms of pipeline of the gas all the way back to shore. And then we have our gas processing plants and the refineries and the petrochemical plants. The total numbers of all of them together are roughly about 30 odd facilities, but these facilities are huge, big, right? All right, and then the processing plants, you find them in Kerteh. The refining plants, we have two, one in Melaka and one in Kerteh. And petrochemical plants, you find them in Melaka, Gurun. Kerteh has a whole complex. Now we have Pengerang and plants in Bintulu and also Labuan. I think I covered them all. So most of these plants and this process units that I talked about is where you will find the most automation. So automation being sensors, controllers, and actuators, which are valves. So they're all heavily utilized in these areas, and this is where you will find most of them. Okay, so the three components: sensors, controllers, and actuators. Okay, they form basically automation in our industry. So sensors. So roughly in Petronas right now, we've got about 120,000 sensors. Okay, so what are these sensors? They are transmitters, they are gauges, they are used to measure the process parameters, right? So because essentially what we are doing is we are moving hydrocarbon from one end, from one place to another location, and while the time that we are transferring them, we are changing their state from between liquid to solid, from gas to liquid, you know. So there are a lot of equipments to do that along the way, which are pumps, compressors, and there are a lot of heating and cooling going on everywhere. So in order to do that, we need all these sensors. Okay, so the sensors measure process parameters like, you know, flow, level, pressure, temperature. Then we have quality analyzers like oxygen analyzers, density, moisture, pH, because these are all requirements of the process itself, right? And then we also have fire and gas detectors because we operate in a hazardous environment, and you need this to prevent any unwanted incidents. So roughly 120,000. And controllers. So controllers are basically distributed control systems and programmable logic controllers, and another category of programmable logic controllers called safety PLCs. They are a bit more robust and higher reliability as compared to the regular programming logic controllers. So what do they do? They basically you know, all the sensors and the valves are all connected to these systems, and they are programmed and automated by logic. Okay, the logics are all stored inside here. So we've got about 5,000 of them, and they also come a bit messy because, you know, they have a lot of subcomponents inside there that need to be taken care of. Like you have your power supplies, your signal conditioners, your surge protection device, and there are a lot of logics being built inside there. And they come with cabinets, a lot of cabling, logic programming, yeah. So messy, and you can find them in the field. You can find them sometimes in control environments in the control room, and you can see from these pictures, yeah, they can be a bit, you know, yeah, a lot of cabling, a lot of very compact and complex stuff. A lot of things you learn in university about microprocessors and stuff are all built inside here. Okay, then let's go to valves. Okay, so valves, we have about 70,000 valves. Okay, so valves are basically two categories: control valves, shutdown valves, and they then are equipped also with further automation devices like limit switches to tell you, to give you a signal whether they are fully open or whether they are fully closed, and then there are positioners to make sure that they are set in the correct position wherever you want them. And there are solenoid valves that open, you know, discharge or admit the air for the valve to move or to close, you know. And then these valves in the picture, they weigh, they have sizes. Okay, the sizes are based from somewhere between 1 inch, half inch, or 1 inch commonly, up to 30 inch. Sometimes you get very big valves sometimes, depending on the process. And they are heavy. They are heavy because for every inch of the valve, depending on the process that you are trying to control, you might have very big actuators. So they are heavy, and in order for us to work on them, if you have to move them, you require crane sometimes, and you have to when unnecessarily you have to drop them to do maintenance. So it can be a bit tricky. And they are geographically dispersed. Sometimes you have it high up in the column, sometimes you have it on the grate if you're lucky. Sometimes they are very compact and inside enclosures. You have to, you know, fold yourself to even reach some of the components. So yeah, it can get a bit tricky. Right? So the three categories of instrumentation and the numbers. So what do we do? What is the function of all this automation? So they are all used to measure, to control, and to safeguard all our operating assets, the ones that I explained earlier, our petrochemical facilities, our refineries, our gas processing plants, our oil and gas platforms, and also the LNG plants. Now, how critical is this? So basically, if there's any failure in any component or any part of the automation, in the worst case, it can lead to process shutdown, which means loss of production. And it could also lead to safety incidents where, because we are dealing with hydrocarbons, it can lead to loss of life, damage to asset, environment, and reputation for the operating company. So I'm sure we are all aware. You have seen and heard a lot of issues concerning the oil and gas industry. So yeah, and they all sometimes resolve back to instrumentation in there. So let's put some things into context. So now, if I have the total number of sensors, controllers, and valves I just explained, it numbers up to about 195,000. Now, for a world-class operating asset, right? If I have 90% equipment reliability, that's actually very, very, very good. It actually translates to mean that I actually have at any given time about 19,540 instruments. They may not all lead to this, but that's the scale of what we deal with. And even if I have this, I'm still at world-class level. So just to put some things in context. So then these are the automation. So let's introduce the instrument engineer in Petronas. So instrument engineer in Petronas, right now, this is as of the last count, I just got this number. We've got about 550 instrument engineers and technicians, okay? Basically, we are automation practitioners. So who are our clients? Our clients are basically operations, and our KPI is to make sure that our clients have reliable instruments for safe and a productive operating environment, okay? That's how we can be productive. So what is our job? Essentially, what is our role? One of our key roles is in maintenance. So our job is to maintain all the sensors, actuators refers to valves, and all the controllers systems to performance, to make sure they reduce the overall life cycle costs. So we have to maintain them in the most cost-effective way to ensure that they are reliable. We have to predict, okay, or any particular faults timely and accurately as best as possible, because we don't want to be reactive. We are all dealing with electronics. Electronics typically have they tend to fail randomly, right? But they also come with diagnostics, right? So we need to be as much as possible predictive, okay, and trying to prevent these failures before they happen. And when they do, our job is then to prescribe the accurate corrective and the right preventive tasks so that we can fix this quick, okay, and prevent further incidents like this. So we do work in all these hazardous environments, and we also do a lot of desktop exercises in office and designing to make sure that we select the right instrument and right automation. So by the way, this is my son lah, maybe future instrument engineer, who knows. Okay. Next, so again, putting things in context, at 195,000 instruments, okay, the ratio is about 350 instruments per person. And going back to the ratio again, at 90% reliability, so basically each one of us has about 35 instrument problems at any given time that we need to think of, and we are still world class at this rate, okay? Now, so of course, this is a problem, but not everything is going to lead to a catastrophic incident or major issue. But these are problems that we need to deal with to improve our operations, right? So how has digital transformation supported the instrument engineer? They have, and how can digital transformation further support the instrument engineer? Right. So that's a brief introduction to to instrument and automation in Petronas and basically what we do. So now what is digital transformation? So here I found this representation to be one of the more comprehensive setups of what digital transformation means. When we normally hear digital transformation, we tend to be very overwhelmed with information, like particularly what you see in this cloud. You have cloud computing, you have big data, we have blockchain, we have IoT, mobile. So we get overwhelmed and stressed, and then we feel like it's something very, very big. Okay. So essentially what it means is that the transformation comes from people, process, and operations and products and services from the company or the person who wants to embark on the digital transformation, and to utilize any of these potential options. Okay, these are all merely options in the realm of digital transformation. Using this to solve a particular problem, to provide superior customer experience or empower employees or optimize business operations in order to help in production growth, increase profitability, and better control of your current processes, right? So for this context, right, about the sharing that I'm going to do, some of the cases, I would like to just focus on us as an instrument engineer, being the people, and understanding our processes and operations, what is it that we do, and how we use big data analytics. Okay, so because as you know, we are instrument, we are dealing with sensors, electronic components. So by default, we produce the most data. All data comes from pretty much electronic components. It's easier to produce data. It's always being present, right? So how we can use big data analytics in order to make us more empowered and optimize our business operations at this moment. Okay, so to give us better control and obviously increase profitability. So when we talk about big data analytics, okay, so this is the context of big data. So it revolves around data science. So data science is a combination of computer science and IT, maths and statistics, and domain. Okay, so as I mentioned earlier, data is widely available and collected in oil and gas. So but a lot of times this data is stranded in the operating environment. Okay, they are sensitive and it's closed information. In order to bring this data out for consumption, then we have to be more, we are exposing ourselves with this data, which may deem to be sensitive, and we are exposing ourselves, which will then incur a lot of cybersecurity elements, which is a totally different topic, and I think that can be another webinar in the future. Okay, so normally we collect a lot of data, we store this data, and we only use it to notify by exception, meaning that the data is being produced and by logic, if there's some alert, we raise an alarm. And if there is a problem that we want to investigate, then we will go back and take out all this data and then make a investigation of how the trend was in the past, right? So there are a lot of data being produced but dormant. And when we talk about domain, right? So in this case, domain is basically the instrument engineer's domain. So we are the domain expert, meaning to say that if I want to make something happen, I must understand my domain, I must understand my business, I must understand my process, so that I can make computer science and IT and this math and statistics work for me to solve my problems. Okay, so I'm going to provide three examples of this, how we have used big data to solve some of our key problems. Right? So the first one is called sensor drift early warning. Okay, now, so before I introduce that, so let me talk about redundant sensors. Okay, so if you can see in this diagram, so this is a process. Okay, I'm using some sensors to detect, let's just say it's pressure here in this pipeline. And if the pressure exceeds a certain pressure, then I want to close all these valves. Right? So sometimes for safety reasons, more than one sensor is used to reliably detect a process parameter. Okay, and most of these sensors today, transmitters, are equipped with diagnostics. So they will tell you when they are faulty, if there is the cable loose, or I'm not getting any power or whatever. It's able to communicate to you and tell you. But sometimes one of the hardest ways to detect a sensor fault, if the sensor basically hangs or drift within its limits, meaning to say that if I were to have an upper limit and a lower limit, okay, if my transmitter either just stays here or it just moves up within the range, it's actually faulty. Okay, but I don't know, because it's still within the limits. It doesn't tell you it's faulty, but it is. So one of the ways that we could always detect if I'm having more than one sensor is to measure, validate, and compare. Right? If by right, they are all supposed to be reading the same parameters. So if I compare each of them, they should be reading and moving along in the same pattern. So if one of them is not, there is an error. And if one of them has started to drift far away and not following a line over time, I can also notify it as an error. Right? So this is something that is readily there because the instrument needs to send the data anyway. Right, so we can just use this. So traditionally, what we have done is we have used measure, validate, and compare in the DCS itself. So if you look at this setup, this is the layer of data flow in our organization. So normally the sensors and actuator produce data. This is the controller. And most of the data is held here. And this OT is called operation technology. So this is in the operations layer. So most of the data that we generate to the sensor is all stored inside here. Okay. So what has been done is that we do the MVC, the measure, validate, and compare in the DCS because the data is here. So it's very simple, like I explained earlier. If between the two sensors, if the deviation between them is exceeding a certain limit, I will have an alarm. So the operator then will see an alarm, and he will have to then communicate to the instrument engineer, because the instrument engineer doesn't sit in this operation or this control room. Okay, he sits in his maintenance building. Then the engineer will then come and take a look and take some corrective action on the sensor. So this is a bit of a lagging system, and we are relying on the operator to pick up these alarms if it comes to them to communicate to us, right? So, but still, it's proactive, but it's a lagging system. Now, over time, as the organization is progressing towards becoming a digital organization, the organization itself realizes that we want a lot of data to be moved up to the IT space. Okay. Now, as this data is being moved out, it becomes easier for people in their offices to get information of this data, right? And a lot of times we keep this data, like I explained earlier, in order to troubleshoot when there's a process problem. Then we go and get the data on demand to troubleshoot something. Now, since this data is dormant, it is the same data that we do it here, that we were doing previously in the DCS. I can do the same logic with the data that is available here. Now, I can even add a few more rules onto the data. Okay, so then you can have the alarm triggered directly to the instrument engineer. Now, this lessens the burden of the operator. Okay, he doesn't have to do the additional task of informing the instrument engineer, and the instrument engineer can have an overview of all the instruments under his care. Okay. So this is something that you, with the existing data that you already have, which was predominantly dormant, we can configure something like this on the platform, where it will just send out an email notification to the relevant person. You can even set it up by telling exactly what is the fault that you have predicted, and it gives you a link to the dashboard that you can just go and take an overall view, and you can actually look at the trend and actually see what is wrong with it. Like in this picture particularly, I particularly took to show you that you can see very clearly that there is a flat line here, and it tells you exactly like which transmitter is now in a single line and it's away from the other two. Okay. So this is one example. So another example is about obsolescence management. Okay. So as you know, we are dealing with electronics. Okay. Now let's. I just took this chart of consumer electronics. We are not far from consumer electronics because electronics is electronics. Let's look at the lifespan of electronic products. Okay. So this is you see the actual lifetime, design lifetime, and a desired lifetime. So the actual lifetime of electronic components is always short. So on average, it's between you get between 5 to 10 years. It's very good, and which is why we change our phones very fast. We get bored of technology, and sometimes we want to change. Sometimes it's just the cost of maintaining it becomes more and more expensive. And like I said, we were dealing with earlier, like close to 195,000 instruments right now, and we have been operating since a lot of the plants came up in the 80s and 90s, so it's a big headache, right? So this does not affect other disciplines so much per se, because we have a lot of numbers, and almost every component is electronic. So we are this is very, very critical for us. So when we want to do obsolescence management, what are the steps involved for us to do? So every asset typically needs to have a database, an inventory, and it keeps changing because sometimes we replace, sometimes it's always dynamic. The number, the brands, the models, different types of categories of instrument, different vendors all over the world, right? So we have to categorize all of them into the different categories. We have to have, and then we have to keep updating ourselves on the data of whether this is obsolete or not. And there's a lot of phone calls, a lot of back-to-back, and I think the vendors also probably receive a lot of phone calls, a lot of emails asking the same questions, which in the end does not necessarily translate to any business per se, because we just want to know. And everybody's asking the same question again and again, right? And this consumes a lot of time, although the information is the same. I might have the same component installed in maybe I have about 200 different platforms, but if it's under the jurisdiction of a different engineer, that engineer will still have to ask the same question because he wants to know. Okay. So this is something that we thought about, and we wanted to consolidate all our instrument model database. So we use SAP, okay, a lot to manage our work processes. The organization has been with SAP for more than 20 years, I suppose. So all our instruments are all categorized inside there. We have a huge chunk of data of as much detail as possible right now as a data source from there. So if we can extract all of those, categorize them nicely out into a database, and if I can publish it out to a website, okay, whereby I give access to my fellow vendors or any information that I have of this instrument and their components to be filled in or to be managed by the vendors themselves. What I could then do with this information from the database is to come up with my own visualization dashboard to manage my obsolescence roadmap for my asset, even for my overall business. So I can get a full roadmap of how many components, what models am I dealing with, and I can get as many information that I want from this system. So it becomes more proactive management of obsolescence. instead of being reactive and having to find the information every time somebody asks the question. Okay, so this is one of the initiatives that we're doing. And another one, another example here is something that it's been done for a very long time. I'll just share with you. This is called a safety valve travel time tracker. Okay, so what's this about? So for our valves, we are to meet industrial requirements operating in a hazardous environment. The international standard that covers this among all the practitioners is basically IEC 61508 and 61511. So as for good governance, we should show compliance towards these particular standards. And one of these compliance is to test our safety valves. Okay, why do we need to test these safety valves? These safety valves are not in operation all the time. They are there in case that there is a breach in safety and you need this valve to respond. So for a very long period of time, these valves will remain in an open position and they only come into action when you need them. Sometimes they are never even called to action for more than 1 year or 2 years, as long as if you have a good period of operating. So how do you know that they are functional? So this is why proof testing is required. Okay, so basically it is just a test, okay, to ensure that the shutdown valves close within a stipulated time. Because if there's a process breach, you want this valve, if it has been designed to close within 3 seconds, you want it to close within 3 seconds. So this task is basically a compliance task to go around the entire facility, okay, to test all these valves one by one and keep a record of them, of their performance. So if you look at the problems, right, we have to set aside a time. Okay, we have manual time tracking is prone to human errors. So sometimes you start the clock, somebody is giving the command from the control room, and then you say, okay, now, and then you press the time. So sometimes it's off by a couple of seconds. So so there are a lot of logistics involved there. You got a lot of valves to be tracked at once. Like I said, the footprint is so huge, geographically dispersed, and you have to travel from one valve to another valve. You have to climb up some structures. It's a very time-consuming affair, and you have to get a lot of physical resources to do this, and there's a cost associated with it, right? And for reporting, there's no time record to confirm with the performance standards, and everything is manually key in if you do this, right? And sometimes you can only this part, no credit to ESD tests in case of unplanned deferment. What this refers to is like there are occasions when the plant trips without you testing it and the valve successfully closes, but you will never be able to know how well it performed at that time, because you only will be able to know when you are physically there and you are doing this test by yourself. So what has been done? This thing has been done for quite some time in some assets, but there's still a lot of gap and a lot of scalability that we can do. We should do more of this actually. So we can automate it using the existing signals in the DCS, right? After all, this is all programming. The data is there. We can just make it happen with a simple programming. So every time there is a command to trip the valve, we will know from the system. The system just needs to keep track of the valve's movement from open to close and just use the counter in the DCS to just automatically record. Right. And then obviously we can generate an on-demand report which is totally transparent, and then you can just focus all your resources onto addressing the ones that have the issues. Yeah, so this is something that can be done, and I think by default a lot of this configuration should come as default in new facilities, new installations, and DCS vendors should have this as a standard template to provide for end users who are embarking on this, because they need to do this anyway. Okay, so these are some of the examples that I wanted to share. So in summary, what I'm trying to explain is that, you know, digital transformation can be overwhelming, can be complex, but it's not possible without innovation. Okay, to improve the business process, you want to optimize the way you do work or your product quality. So the innovation needs to come from yourself. You need to understand who your clients are, what is your task that you need to do, and you need to have good domain knowledge. So we must understand as instrument engineers, what is our business, what are the current processes that I need to do, and how can I innovate them in the most cost-effective manner? What do I have at my disposal? It doesn't have to be very big in nature, because digital transformation allows many areas, but we can what is the most easiest thing that I can do with the existing resource that I have? Okay, and then digital transformation is not perfect. Okay, but with an innovation, you can start with incremental milestones. So, like for example, the earlier innovation I shared about the tracking of the DCS, that was done in 2015 by one of our engineers somewhere offshore, and it has got a lot of traction. And we are constantly improving the way it is represented, the way the logic is done, and scaling up throughout the rest of the business, right? So this innovation is constantly evolving. So basically, this digital transformation for a big organization like us happens when every subcomponent has an innovation idea. So the collection of these ideas are the ones that make an organization basically digitally transform. So the engineering mindset that we need to have as engineers in automation with digital transformation is that, you know, we need to be curious, we need to be adaptable, we have to have this innovative mindset on how we can do things better. We have to be open and not so rigid in the traditional way that we've always been doing things. We must understand our domain, we must understand how our instrument work, but we must challenge the norm. Okay, we should also be resourceful to see what data that we have, what can we work with now, and a bit of willingness to take some risk to try out something, because there's every chance that you might not get funding, you might fail, and you can always keep doing whatever you were doing because it worked. Okay, so this is some of the conclusions that I have, and I think I've come to the end of my presentation. I think it's 11:50 about time. So yes, thank you. And yeah, simple quote here. And yes, that's it. I'm done. Thank you. Thank you.
Thank you, Suren, for your great presentation just now. So for every one of our participants, I have shared the feedback form in our chat box, and really appreciate as a motivation to our speaker and the organizing committee. Kindly provide your feedback to see how we can improve, and also what would be the future topics that you are looking for the coming webinar series. And now we are entering the final leg of our webinar for today, which is the Q&A session. And yeah, Mr. Suren, just be ready.
Yes. Welcome. Most of this be interactive.
Okay, so I will open up the floor to everyone. And gentlemen, please just should anyone having any questions, kindly just unmute yourself and just ask away. Okay, so maybe just taking the lead, I will just after your presentation, Suren, I have actually questions that I would like to ask to you, while others are maybe having some thoughts over digesting the slide. What are the challenges of collaborating with the vendors in driving all these new technologies and solutions that you are taking lead on, Suren?
Okay, thanks for that question. I think the vendors themselves have always come up with a lot of interesting products, and I think they have their own roadmaps on how to improve their own offerings in this arena, basically to improve our operations with digital transformation products as well for us to adopt. I think sometimes they work for some organizations, sometimes they work because if we understand the organizations like Petronas, we are big, we are huge, right? So sometimes we have our own digital transformation aspirations. So it'd be good that sometimes it's difficult to adopt an offering or a product wholesale, because we deal with so many vendors, we deal with so many products, and they're essentially the same offering, because everybody is moving to develop the same kind of solutions. So I think for vendors, being flexible in helping an organization like us, we have our own aspirations, right? So we want certain customizable kind of solutions, technologies to help us meet our aspirations, also in the digital area. So I think that flexibility is very helpful to us, and there are some vendors who have actually done that. So for example, when we wanted to do this logic in the DCS for the valve time tracking solution. So I think that customization, that understanding of what we want to achieve and how they can do it, was good, because it's a one-off thing. It was not a product, but at least it is something that was offered in order for us to meet our aspirations. So we want that kind of collaboration, so that we all meet our aims, rather than just taking products. Some organizations who are very lean, standalone organization, I think, who are willing to outsource their automation, their maintenance, I think then having a one-stop product works. So I think that is a bit of a challenge and opportunity, I would say, that we have in this digital transformation.
Well noted. Thank you very much for the explanation. So to our participants, hope that Mr. Suren's feedback or answers will give you some clarification. I also received another question. I don't know who is so shy, just pinging on the side. They said that the questions I'm helping to ask is, in your opinion, Mr. Suren, what skill does an automation engineer needs to have to excel in all this big data analysis, etc.? What would be the right skill to have? Because we are big data is current trend, right?
Yeah, I do think fundamentally, if we look at instrument or automation as a field, we need to be strong in our domain first. We need to understand what is it that we do. Okay. To complement it with big data, with analytics, of course, there are so many areas of understanding how new technology works, how IoT works, how to do programming, how to do, because those things add a lot of value, but at the same time, you need to know what is it that you want to do. And for us, what you want to do relies a lot on understanding what you are looking after. So I think it needs to be a balance of both. For having the domain knowledge, the knowledge of instrumentation is key, but to complement it in the modern day, I think a lot of programming, being technology savvy, being open to new technologies, and being a bit of a risk taker and understanding how you can do things is how you can make things happen is quite good. And I think one thing that I need to add on is that we are basically engineers to solve problems. Okay, we want to solve problems, and we always want to solve problems in the most resourceful way. I mean, you always, engineers are always about solving problems. So in order to solve problems, sometimes you don't solve problem yourself, right? So you need to be able to collaborate and have a bit of interaction with people who are able to do this kind of thing. So if you can translate your requirements as best as possible, so somebody else can also help you with his skills. So it's impossible in this day and age to know everything. So you need to be good at something, right?
Thank you. We have another question coming from our participant, Mr. Hakim Ismail. How have Petronas capitalized and realized the benefit of big data?
Oh, okay. I think we okay. Put me in a spot to answer in terms of that. I think we are just like any other organization. We have aspirations. We understand this is important. Data is the new oil. It's a transformational journey, and we are still there. And I think we have done a lot. And firstly, the organization has equipped a lot of us with reskilling and making sure we are all digitally enabled, understanding all the requirements, like how to be agile, how to be innovative, how to understand cybersecurity, how to manage data. And they've always been promoting us to be innovative in our day-to-day work and adopt technology. So I think, and they've also provided enough resources for us to become a digitally enabled organization. The opportunity is there, and it's still a journey, but we have come a long way actually. I don't think I have enough time to give enough examples, but yes, I think we have done a lot in terms of the digital space. And every business, every asset, every discipline from the businesses, from finance or procurement, everything has we have transformed quite a lot using this digital, trying to be a digital organization. I hope that answers the question. I cannot give enough examples. There are too many.
Thank you. We also have our ISA president and Cheryl raise his hand. Cheryl.
Okay, I would like to help on expanding the answer for the first and second question.
Thank you, boss.
Okay. The first is how to be better, right, as an instrument engineer or automation engineer, correct? When I was in MLNG, I encountered this one guy. He was a technician. His name is Bun Jampo. And he is very smart in a way that when he's solving problem, when we asked him to resolve problem, he didn't go and straight away resolve problem. He asked, "What's the problem?" He asked the operator, "What's the problem? When it's happened?" He put a lot of question to the operator. Because as an instrument engineer, instrument technician, of course we want to resolve problem, but what is the problem? Is it the process that's causing a problem? Is it the sensor haywire causing a problem? So we need to discriminate, ability to discriminate between process issues or issues that is coming from the instrument. Of course, issues that coming from instrument can come from the loose wire, can come from the rains overnight causing the wet wire and intermittent shorting. Intermittent is the biggest problem that very difficult to resolve. Okay. So ability to understand the process, the ability to understand process, master the process, will make you a difference between just a regular instrument engineer and a better instrument engineer. Okay, that's number one. Number two is on, what is the second question, Ren?
It was about the Petronas digital,
Okay.
how have you?
Okay, because of the digitalization, the IT is pushing all the way to the OT environment. When it comes to digital, the technology in the IT is very much mature. Cybersecurity, digital science, analytics, open system. Our instrument is very much closed, very much proprietary, very much close, and then we are not able to send the data easily, freely to the enterprise. So because of that, because of that, there's a limit. There's a limit that we can do. So that's why the digitalization is actually pushing the demand for us to push over the data all the way to the enterprise, to the cloud, because the cloud has all the engine, the AI engine, the analytic engine that can do the wonders, that can predict, prescribe, that Suren has mentioned just now. So that is why to become a better, to respond to the digitalization, as an instrument engineer, sometimes you may have to upskilling yourself. Upskilling meaning to say you have to know, understand the cloud, the enterprise. You have to understand when you are sending data to enterprise, there are cybersecurity threats. So you have to learn a little bit about what is angle of cybersecurity that can affect sending data to enterprise, so that you will not be simply bullied by other people. So you have a stand on, because instrument, the core is, we have a core. We have to protect our core. We have to grow beyond the core to meet the end objective of the company, which is to the enterprise. That because of digitalization. One day you want to remote operate. How can you remote operate if you still worry about all this cybersecurity? You're still worried about the reliability of the data. You're still worried about the connection, the connectivity. So you need to strengthen your core and grow over and understand other skilling that you need to be able to support the mission vision that to become of the digitalization. Things. Okay, if you remember, if you know now, if you are aware, by mid-2022, there is a push of this Ethernet APL, Advanced Physical Layer, that will make Ethernet available at the field, which means all the transmitter now will have his own IP, and all the transmitter now is able to send full diagnostics, full information all the way to the enterprise, of course, within the cybersecurity framework. It is not just like a field bus. It is an improved design version of the field bus, because everybody knows field bus has its success story, has its failure story, more towards failure. So, but APL, Advanced Physical Layer, it is a new revolution that is pushing the Ethernet to the field, where all your individual transmitters are now connected and having the IP address. It is superior than your hard IP, because why hard IP is there? Why hard is there? Because they have to have diagnostics to be sent over for 20 milliamp. But now with this Ethernet APL, Advanced Physical Layer, you don't need that hard anymore, because you have all information that you can send through the data frame, through the IP address. The moment you have IP, you can send everything that you have in the transmitter to the enterprise, because of IP, of course. So that is the, in a nutshell, digitalization for instrument is you need to upskill. Maybe you may have to reskill, but at the same time, protect your core. Okay. Thanks. Thank you very much.
Thank you, Mr. Sharul, for your very insightful feedback and opinion on this. And I think in lieu of the time, we are at the end of our webinar, 1 hour session for the webinar. So maybe we have the last 2 questions. I think we can combine together and ask to our speakers or anyone who are interested to answer. First from Mr. Chan Wee Xiang, how we quantify on the investment and return ratio of this digital initiative, and also from Mr. Hakim, is there any estimated return of investment for implementing big data for an instrumentation project? I think these are similar questions. Maybe
yeah, it's so I think I would like to answer that in one way. If you recall, if I take you back, if you notice when I did the context setting, right? So we've got so many instruments, and how much to achieve world class, right? So these are our core job. This is what we need to do. So this is traditionally what we are doing. So the return of investment is very simple. If I am doing something with data which is available, every digital transformation project lies on data. So now there are two things about data. The cost of a project, a digital project, is twofold. It becomes much cheaper if I already have the data. It becomes very expensive if I need to make the data available. The cost of making data available makes the whole project expensive. Now, if I'm already working with existing data, the return on investment become very, very fast. It's the same everywhere. If you're working with something that you already have, then it's a very quick fix for you. They call it low hanging fruit kind of thing. So if I'm making my job easier, if I'm making myself more productive, looking after more things with less resource, I think it pays by itself. There's not much to do that. It's only justifiable when you need to have a big investment. Now, the return on investment can always be associated with how much of problems do you actually have? What is the impact of the problem? And because we are dealing with something quite critical here, there's a lot of ways to justify certain initiative. So for example, like when we talk about obsolescence management, it's very easy to justify, because every single time I do a study, sometimes I don't do it myself. I will engage somebody else to do this study for me. Okay, come and compile for me and tell me all the obsolescence data. If I'm paying X amount every time somebody comes and he takes a few months to come and do this study, if I multiply this across, right, I will immediately know how much my recurring expenses just to find out this information. Then I can easily, translate it doing the cost benefit analysis. Okay, if I spend this amount of money, I won't have to do this anymore in the future, and I save it for the rest of the. So there must always be some cost benefit analysis, but that is what we undertake. Like this is our due diligence that we do. And I think the organization now also is moving towards validating all these initiatives, because we don't want our ideas to just be an idea. We spend money and then it doesn't return anything. So there's a process in place to make sure that we validate that our clients want something like this. This really is going to provide some benefit before we get the investment. So it's not that easy to get the investment out as well. But some things can be done very easily.
Okay.
I hope that answers that.
Yeah. Thank you, Suren, for the answer. And I think it's the end of our webinar for this month, and we will be hosting our new webinar with the new link for the coming ones in March, and hope that everyone is able to fill in the feedback forms and also provide your input on what are the topics that you are looking forward to. So Suren, I think it's a wonderful time that you have spent bringing us along the aspects of digital projects. As also an automation engineer, what are we doing with it? So I would like to thank everyone for participating for today's session, and we look to see you again in the coming series. Thank you very much.
Thank you.